Welcome to Unit 1, Lesson 3, A Gallery of Data. Our learning goal today is to make, compare, and interpret data displays. You have one learning target for today. By the end of the lesson, you want to be able to say that you can graphically represent the data that you collected and critique the representations of others. The vocabulary for today begins with categorical data. Categorical data are data where the values are categories. For example, the breeds of 10 different dogs are categorical data, things such as golden retrievers, pit bulls, and chihuahuas. Another example is the colors of 100 different flowers. So if I want colors, that might be red, blue, orange. But my answers are categories. That makes it categorical data. Next, we have distribution. For a numerical or categorical data set, the distribution tells you how many of each value or each category there are in the data set. Five-number summary. The five-number summary of a data set consists of the minimum, the three quartiles, meaning Q1, median, and Q3, and the maximum. It is often indicated by a box plot like the one shown, where the minimum is 2 over on the left. The three quartiles are 4, which is Q1 and makes the left side of the box, 4.5, which is the median and makes the line in the middle of the box, and 6.5, which is Q3 and makes up the right side of the box. And the maximum is 9, which is the far right line. Non-statistical question. A non-statistical question is a question which can be answered by a specific measurement or procedure where no variability is anticipated. For example, how high is that building? There is only one correct height for the building. If I run at 2 meters per second, how long will it take me to run 100 meters? There is only one correct answer. You would divide 100 meters by 2 meters per second, and your answer would be 50 seconds. Numerical data. Numerical data, also called measurement or quantitative data, are data where the values are numbers, measurements, or quantities. For example, the weights of 10 different dogs are numerical data. Numerical data is the type of data you're going to have to use for your Unit 1 group project. So make sure that when your team decides on the question they're going to ask, that question will get you numerical data for your answers. Statistical question. A statistical question is a question that can only be answered by using data and where we expect the data to have variability. For example, who is the most popular musical artist at your school? This answer will be different at each school. When do students in your class typically eat dinner? People eat dinner at different times. And which classroom in your school has the most books? This could change from one school to the next. So when your group is doing their Unit 1 group project, remember that your question needs to be a statistical question so that you are getting a variety of different answers in order to create your plots. Now we can look at the practice problems for Lesson 3. The box plot represents the distribution of speeds in miles per hour of 100 cars as they pass through a busy intersection. Number 1, what is the smallest value in the data set? Interpret this value in the situation. So for number 1, we're going to find the smallest value down here at the left end. We can see that that lines up with 8, and that's miles per hour. So the slowest car is going 8 miles per hour. Number 2, what is the largest value in the data set? We'll find that down here on the far right hand side, and we can see that the line is at 44. So for number 2, the fastest car is going 44 miles per hour. Number 3, what is the median? Interpret this value in the situation. So the median, remember, is the middle number. So on a box plot, it is the line in the middle of the box. This line is directly above 20, so that means the middle car is going 20 miles per hour. Number 4, what is the first quartile, Q1? Interpret this value in the situation. So first quartile is the left side of the box, and this line is directly above 12. And what the first quartile tells you is how fast up to 25%. So this tells you 25% of the cars. In this case, since this is 100 cars, that's 25 cars, go slower than 12 miles per hour. And finally, number 5, what is the third quartile, Q3? Interpret this value in the situation. Q3 is the right side of the box. So this tells us 24 miles per hour. So this means 75% go slower than 24 miles per hour and 25% go faster than 25 miles per hour. So because we know it's 100 cars, 75% of the cars, which is 75 cars, go slower than 24 miles per hour. So this is how we analyze a box plot. You have the left whisker, which tells you the minimum. You have the right whisker, which tells you the maximum. You have the box, which gives you the middle 50%. The left side of that box is your Q1, so that divides it into the lower 25%. The line in the middle of the box is your median, which means half is below and half is above. And then the right side of the box is your Q3, which means 75% is below it and 25% is above it. If you have any questions about how to solve a problem that involves interpreting a box plot, please use class time to ask for further clarification. Our other practice problem. The data set represents the number of eggs produced by a small group of chickens each day for 10 days. That means each of these numbers in the data set is a number of eggs produced on one day. Select all the values that could represent the typical number of eggs produced in a day. So notice the word typical. Typical means your average or your middle. So typical has two meanings. It can be mean or it can be median. Now median is the middle number. So if I want median, I have my 10 numbers. I want to draw a line right in the middle, which would be between the 7 and the 8. Now 5 of the numbers are smaller, 5 of the numbers are larger. Since these two middle numbers are not the same, we need to add them together and divide by 2. 7 plus 8 equals 15, and 15 divided by 2 equals 7.5 eggs. So one possible correct answer is choice A if we want to use the median as the typical number. The other choice is to use the mean. So to find the mean, you're going to add all the numbers together and you're going to divide by 2. So we can use a calculator. We have 5 sevens. So 5 times 7 plus, we have 4 eighths. So 4 times 8 plus 9. So total, this is 76. And we're not dividing by 2, we're dividing by how many there are. So that's 10. So if we divide 76 by 10, we get 7.6 eggs, which is choice B. So choice A is correct if we use median as our typical number, and choice B is correct if we use the mean as the typical number. If you have any questions about how to find the median or the mean, please use class time to ask for further clarification.